Hi everybody, welcome back. We are now going to talk about rational functions, and one of the first things we should learn about rational functions are their vertical asymptotes. So just a definition here to remind you what an asymptote, or excuse me, what a rational function is. So a function is rational if you can find two polynomials, p and q, such that p divided by q gives you h. The only thing we have as a restriction is q cannot be the zero polynomial, or basically q of x, 0 for all x. So we can't have that, but anything else can be in the denominator. So basically, if your function is non-zero for one value of x, it can go into a denominator of a rational function. And so when we draw graphs of functions, these lines called asymptotes help us define the shape of the graph. So we're going to first talk about vertical asymptotes in this video, and then we'll talk about horizontal videos in another one, and then other types in a third video. So what is a vertical asymptote? Well, basically, the idea here is a vertical asymptote is a vertical line, and they exist when the value c here makes the denominator equal to 0. So basically this sets up a nice little procedure right here that you start off by setting the denominator equal to 0 as some side work. You solve for x, and if you get any real solutions, then they correspond to the vertical asymptotes, but it's also possible that you don't get any real solutions, and that means that there are no vertical asymptotes for that particular graph. So let's look at an example here. Find all the vertical asymptotes of this function. So we have to do some side work here. And even though I'm calling this side work, even though this is the main work of this problem, when we go and do the actual graphing, this will be actually side work for the graphing problem, so that's why I'm calling it side work now as well. And what we want to solve is the equation x squared minus 4x plus 4 equal to 0. So this factors, this is going to be x minus 2 all squared equal to 0, and taking the square root of both sides, we get x minus 2 equals 0, so x equals 2. So this is a 0 of the denominator. And this corresponds to the asymptote, which is a line, x equals 2. So notice that this gets a little very similar because they're in correspondence with one another. So if you find a 0 of the denominator, that gives you an equation of the line. So the notation is supposed to suggest a relationship between the two. So the fact that they have the same equation representing two different objects is totally fine, and it's there to remind you that these two things are related. So that's my example here. So we'll move on to horizontal asymptotes, which are a little bit more tricky. And then after that, other types of asymptotes. See you then.